significant. The American Statistical Association actually has a magazine named Significance. All of statistics deals with significance. I could say that something has a change, but is that change significant or not? That is the bigger question. Why do I have to ask that question? Well, we deal with random things in statistics. For example, let's say we are testing a drug for anxiety. Do you believe that if I administered that drug to 20 people, recorded how they did after 7 months, do you believe that every single one of them would show the same type of prognosis? Absolutely not. There is variability, so things are random. Let's say, based on those 20 people, I come to the conclusion that I have a great drug that can be approved, that can be prescribed, etc. The next question that I need to answer is it significant, or am I just observing some random result? So that is what we mean by significance. Majority of you, pretty much everybody here, are in social sciences. So hypothesis testing is one way to assess significance. But there are other things such as confidence intervals, meta-analyses, all sorts of stuff. We will talk about a few of those, just an introduction. Those are advanced topics. So our goal is to establish significance, and in addition to that, there are 2 types. One is statistical significance, the other practical significance. Something might be statistically significant, but not practically significant. So the Declan mentioned P-level, then we can conclude that it is a significant change. Most people will just stop there. And later you will say, well, just because you got a p-value of certain p-value of say 0.025 and less than 0.25, you concluded that something is statistically significant, doesn't make it practically significant. There are reasons for that. I'm not sure if you've got covered it, but when we get to chapter 8, alpha, beta, all of those will come into play. Are we clear with this part? Statistical, practical. So step 1, we've got to establish statistical significance. Once we do that, we assess whether it is also practically significant. So if both of them are present, you establish statistical significance, followed by practical significance, then you have a significant change or significant effect. I'll explain what effect is. So, good so far? Okay. Now, last time I mentioned Chapter 7 is crucial. If you understand the procedure, everything else that we would do this semester are simply variations of this procedure. So it's very important that you understand the procedure, the rest will be a breeze. Good. So people who took 2023 or reviewed hypothesis test, what are the two components of a basic hypothesis test?
Random sample independence.
Right, oh, those are assumptions. We will talk about
Yeah.
that.
Formality.
So prior to that,
But you want to have a statement of your hypothesis.
okay, we
And
would, go ahead, did not interrupt.
and you want to know what you are trying to find. Like you want to have the I forget what they're called. You want to have everything set out. Like you want to have the null hypothesis set out.
Okay, we'll just throw another word, null hypothesis, okay? The null and the alternative, who took 2023 last semester? Remember, is it coming back to you? No. Just learn using the calculator. So there are two pieces to a definition of a test. That will be your first step. Null, alternative. From a theoretical standpoint, we test for the alternative. And earlier, Declan mentioned change. So the question to ask would be, is there a change or is there no change? Do you? Yes. If I have to put it in other words, I could say, is there an effect or is there no effect? Yes. So our goal is to establish significance. Significance of what? Significance of some effect. That could be anything, but statistics deals with math or uses math. So I'm going to start with mu. Mu. Do we remember? What is it?
Average, the mean.
Mean, Olivia? Mean, okay, here is a question. Which mean are we referring to? Population mean or sample size? Population mean. Can someone tell me the difference?
Well, the population is the mean taken from basically everyone, general population. And then there's a sample mean, which is taken from a specific sample that you're looking at.
Did you hear the word? Or no? No? Louder.
The mean of the population is basically taken from like the general population, and then the mean of the sample is taken from the sample that you're looking at.
Okay. Do we agree? Yes. So I don't use TikTok, but if I'm interested in the average time a student spends on TikTok per day, that is of interest to me. That will be me. Good. I'll explain an example. So average time. Such a waste of time. could do a lot of other things instead of this. That's an opinion you can say. But I'm wrong, but that's okay. Regardless. Do I know the answer to that? Saying no. So Sophie says no. Why? Full of
It's a very broad term.
people, students, right? I want to know the average time a student spends on TikTok, and that is a large pool. There are a whole lot of students just in the state of Florida, and then you've got all of the other states. Even if I narrow it down just to Florida, I have a whole lot. So I do not know what that is. Do we agree? Okay. So this is a no. The unknown value of the mean is the population mean. A rational thing to do would be to select a bunch of students and ask them, how much time do you spend on average, on TikTok per day? Right? If I randomly picked a bunch of you and I asked you, I'll have a sample. I can use this sample to, get more knowledge and answer that question. So great. Your book refers to the mean that we obtain using a sample as M. You might have seen it as X bar in your previous classes. If you Google, you are very likely to see X bar. Sample average, it is simply an estimate for mean. I do not know the mean. I collect a sample and I come up with an estimate for mean. Good. The claim that I got that average, the unknown value is greater than 3.85 hours per day. Good so far? Mu is not the truth. It is not the known value. We don't know what that is. The entire purpose of collecting a sample is to get knowledge about mu. That's it. Let's say I collected a sample. Hypothetical example. For instance, I randomly selected 82 students, did some math, or used your favorite device in this entire world other than your phone, TI-83 calculator or 84. Let's say you put the data in, you got a value, the value ends up being 3.92 hours per day. So that is the claim. I would like to know if there is some support to that claim that Alyssa made. Yes, that's what I would like to. Let's take that value or expression, put it right here. That is the claim that Alyssa made. And I want to know if the data supports that statement. Quickly, okay. Well, I've got another piece, so I've got to look at the opposite. So what is the opposite of greater than?
Less than. Wait, less than or equal to?
Less than or equal to. I know your name too, because me. Do we agree? It's the opposite. Earlier at the beginning of class section, Declan mentioned equal, not equal. Yes, this is what he was referring to. The equal sign must be in the null. You can't put an equal sign here. When I get to the next step, I'll let you know why. Good so far. In slightly advanced terms, this statement, the claim that you're testing, will be your effect. Good. What is the opposite of an effect? Okay, let me paraphrase that. What is the opposite of significant effect is present? Opposite. There is no significant effect. Let's put it that way. So effect. Should make sense now as to why we call this null. Null means nothing, nothing, no, no significant effect, null hypothesis. Good? Okay. Next step. Is to check for assumptions. Then you've got to ask yourself, well, what is the comparison distribution? I'll tell you what the comparison distribution is in a bit. What you don't want to see. So once we have the comparison distribution, we compare the sample distribution to the comparison distribution to come up with a conclusion whether we have a significant effect or not. But if you paid attention, when I was explaining this, I kept saying, well, how far should I go, right? How far is far enough for me to support Alyssa's claim? Cutoff point. So in this scenario, when I explained it earlier, I know the overlap is minimal, very small. Small overlap, naturally, we concluded significant effect. Too big of an overlap, not significant. cutoff is over here, let's put the cutoff over there. Cutoff, critical value, one the same. If you compare those two, I'm saying, well, if whatever distribution you have, majority of it goes past the cutoff, I will reject. Okay? It went past the cutoff, hence I reject. There, that's not the case. Good. So this picture business, we're not going to do. First step, define. Second step, check for assumptions. I'll tell you what the assumptions are. Identify the comparison distribution. I'll tell you what the comparison distribution is. And then we directly go on to finding the critical value. Can someone tell me what is one way or two ways you used in your previous task class to find the critical value?
The Z-score, right?
True, but how did you find it? What did you use?
It was like a formula,
Okay. What is your favorite device? Second favorite device? Calculator. So you might have used something like inverse norm. Is it coming to you? Or your professor might have tortured you by looking through the table. Did someone use that table? I'm not going to. So there are cases where we have to, due to limitations of this course. But no, we are going to rely on technology. We have it, we're going to put it to good use. So depending on the distribution, we are going to use a calculator to come up with the cutoff. Once you have the cutoff, I want to know if I cross the cutoff or not. Excluding the theoretical aspects of things, we don't make a direct comparison between the null value and whatever we got from the sample. I started it this way so that you will understand the concept. But from a theoretical standpoint, we don't compare whatever Lisett claimed that directly to what the sample is giving us. Declan mentioned Z-score, we have T-score, we have F-score, all kinds of scores. So we are going to come up with a test statistic. Some books would refer to it as a test score. And of course, we will need the sample to come up with the test statistic. Almost there. Last step, we compare crucial step. You're going to make a conclusion. How do we make a conclusion? If you go back to the way I explained, just for the sake of explanation, I compared what we had in the claim to what the data had. we looked at overlap, we looked at cutoff, and we said, oh, sure, significant, not significant. The proper way in terms of theory, you get the critical value, you compare whatever test pool you have that comes from the sample with the critical value. That will give you the conclusion. Good. In social sciences, more often than not, the test that people use is right-tailed. We will save that for later. The conclusion could be one of two things. You either reject the null or you do not reject the null. One of two things. I want to rewrite step one. Null means no significant effects. I can't help. I'm surprised. I know why that happened. The steps that I combined, your book breaks it into two. I believe it has 6 steps. But 5 is traditional. You get the test statistic, compare it to the critical value. You come to a conclusion, either say reject or you do not reject. One of two. Once you pick that part, I can answer the question that I started. I wanted to know if there is enough evidence or support to Alyssa's claim, which is right here. In other words, is there a significant effect in supporting Alyssa's claim? Hypothetically, I'm making this up. If I said I did this test, I've rejected the null. I'm telling you, I've rejected the null. Do you think that we have evidence to support Alyssa's claim? Yes. Reject the null means I'm getting rid of that thing. What do you leave behind? H1. What is H1? Significant effect. Significant effect of what? Alyssa's claim. Good. So we check that part. So this part and that part, they are crucial to getting the conclusion. This is where formulas come into play. I will introduce you to simple formulas. But above all, what am I interested in? Mentioned this last class. Understanding what's going on. You should be able to read a scenario and come to the proper conclusion. Are we clear? If you don't define things properly in this step, when you come here, you will mess it up. So, very important. Make sure you define things properly.